Greetings, everyone. Welcome to our restoration webinar series, Restoring Landscapes from Seeds to Success. My name is Eric Winford. I'm a assistant professor of rangeland ecology at the University of Idaho and also serve as the associate director of the Rangeland Center. My colleague in this is Lauren King, an extension educator with the University of Idaho in um, Benoit County. Right, Lauren? Okay, got that.
Yep, that's right.
So we're starting off this webinar series this year, focusing on riparian restoration assessment techniques. We have a YouTube channel where this um, webinar and all prior webinars from last year have been posted, and I'm going to put that into the chat so you can look at that. We'll be posting these videos. It usually takes me a week or two after the uh, webinar to actually get the videos posted, but you can see the ones we've had and all the Range on Center videos and the Seeds webinar series there as well. Today, we are fortunate to have Kirby Lau with us. Kirby Lau is a recent graduate from the University of Idaho, where she got her master's studying the indirect effects of herbicide on wildlife habitat. Currently, she is working on a riparian assessment project for the university, and which is what she's going to be talking about today. Thanks for joining us, Kirby. And the program for today is Kirby will give her presentation, and then we'll have time for questions. So please put your questions into the chat or the question and answer box on the webinar, and we'll get those, work through those once Kirby's finished. Okay, Kirby, thank you so much. Take it away.
All right. Yeah. Thanks to everyone for joining in on this call today. My name is, as Eric mentioned, Kirby Lau, and I am a riparian research technician at the University of Idaho, where I'm working on a restoration project focusing on assessing stream condition and implementing low-tech riparian restoration at Rinker Rock Creek Ranch. So today we'll talk a little bit about first the degradation of riparian areas and how to assess them. And then we'll touch on a case study showing the results of our 2025 survey and implementation efforts. And then finally, we'll talk about a side project we've been working on regarding the different methods of assessing riparian area status. And I'll also ask that everyone bears with me today as I've got a pretty vicious cold that I've been trying to kick. So if I have to blow my nose occasionally, just mute me or I'll try and mute myself. So I really appreciate your patience with that. All right. But before diving into our case study, I think it's important to establish the role of riparian resources in dry western landscapes. Because, as many of you are likely aware, in the sagebrush steppe, water bodies in the form of streams, rivers, and lakes provide crucial resources for humans, livestock, and wildlife. These wet areas offer opportunities for people, such as recreation and drinking water, as well as food and water for animals. This fact is particularly important here in the arid West, since these wet areas create green islands of food during the late summer months when plants in drier upland areas die off. However, riparian areas can vary in condition and functionality. So some are fully intact, like this stream pictured here, with many riparian vegetation species, adequate sediment retention, and low banks. These streams are able to hold water for longer periods of time, experience less erosion, and provide riparian food resources and habitat for wildlife. Other streams, however, might experience degradation that limits their functionality, such as these two streams pictured here. And there are, for our purposes today, 5 different states of existence for streams in the sagebrush steppe. This includes functional, vegetation impaired, channel impaired, degraded, and recovering functional streams. Managers can classify stream reaches into these categories using pretty simple visual cues, so no measurements are actually required. Those cues include things like for a functional stream, for example, up here on the top left, um, you might see multiple age classes of woody riparian plants, dominant riparian vegetation, low banks, and meanders in the stream. For a vegetation impaired stream, you'll notice a lack of riparian vegetation, encroaching upland species like sagebrush and upland or pseudo-riparian grasses moving into the riverbed. And then you'll also see stressed riparian vegetation, so browning, not looking super healthy. Then for our third state, which is channel impaired, you'll notice erosion of the banks. You'll see soil falling into the stream bed, and I know that picture is super tiny there, but you can kind of see it there where we've got these chunks of soil and vegetation falling into the water. You'll also see exposed roots and steeper banks. And then for recovering functional streams, you'll notice upland terraces. So you'll see upland areas outside of the floodplain or on the edge of the floodplain with upland vegetation covering them. You also see meanders and multiple age classes of stabilizing riparian vegetation. So this is starting to recover, but it's not quite there yet. And then finally, for a degraded reach or a stream, you'll see exposed roots and erosion and a lack of riparian vegetation. So you're noticing qualities of both channel impairment and vegetation impairment together. And that is what you'll see in a degraded reach. But these states aren't static. They actually are fluid and they're constantly moving and changing. And so, with changes to the environment, such as fires or floods or management activities, a riparian area can actually transition from one state to another. And this process can be distilled into this adapted figure here, which shows the loss of specific functions that can cause a reach transition from one of these five states to another, such as from functional to channel impaired, which is facilitated by extreme erosion events, head cutting, mechanical channelization, or from vegetation impaired to degraded, which is primarily caused by stabilizing vegetation loss and restricted floodplain access. Or, for example, from functional to vegetation impaired, which is caused by drought and overgrazing, an invasion of pseudo-riparian or upland species, and so on. And so these are the processes or the loss of natural processes that can cause a stream to transition from one state to another. But like I mentioned, these states aren't static and irreversible, and we as managers can actually improve these areas using low-tech, process-based restoration structures, including things like beaver dam analogs or BDAs, post-assisted log structures or PALs, hay bales, and Z-dike structures, which are essentially rock stack formations, and more. And these are all relatively simple to install, requiring minimal equipment and, for the most part, only a small crew. And they're actually, they've been shown to be pretty effective at slowing sediment loss and allowing native vegetation to establish. So they, for the most part, have been found to do what we were hoping they'd do. And with the help of these structures and other efforts, we might be able to get a reach restored from one state to another more functional state. We added these restoration actions in green to the previous figure shown here. And these actions are aimed at recovering specific processes. So they might include promoting beaver activity and installing BDAs to slow sediment loss and return a reach from channel impaired to functional. Or it might be reestablishing native vegetation through planting and seeding to help restore a reach from vegetation impaired to functional. Um, and these are just, of course, some of the actions that managers can take to improve stream functionality. And so in Idaho, a landscape dominated by rivers and streams, low-tech process-based restoration, like we saw in the previous slides, has become a major area of interest for many agencies and landowners. This presented a great opportunity for us at UI to test the effectiveness of this type of restoration in the case study that we're going to dive into now. So, with funding from the Office of Species Conservation, we aim to address stream degradation locally at Rinker Rock Creek Ranch in south central Idaho. You'll see that on the map. And the ranch, as some of you may know, is cooperatively owned and operated by the Wood River Land Trust, the University of Idaho, and the Nature Conservancy. It's also surrounded by tracts of BLM and IDL lands, all of which, when combined, encompass a pretty large tract of mostly intact sagebrush steppe. So it's a pretty unique ecosystem we've got there. Not only that, but Rinker encompasses much of the Rock Creek watershed, which is a crucial resource in the otherwise relatively dry desert that we affectionately call the Sagebrush Sea. And so this oasis of sorts creates vital habitat for many sageland species, including the greater sage grouse. And knowing this, the overarching goal of this project has been to better sage grouse habitat through the improvement of mesic zones, which sage grouse rely on for food while they're raising their chicks. And today we won't spend a ton of time discussing how this project pertains to grouse and wildlife habitat. But just keep it in the back of your minds to help give us some context as to why we might prioritize certain areas for restoration. So, to create that better habitat, we had to achieve many sub-goals. First, we needed to assess degradation of riparian areas across Rinker. Second, we needed to create a map of those areas and then create prioritization lists. And third, we wanted to plan and begin restoration activities. And so for our purposes today, we'll be using this project here at Rinker as a case study for discussing how to first assess stream functionality, second, prioritize areas for restoration, third, implement restoration structures, and then to talk about the different methods and tools available to help us do all of this. So to begin addressing our project goals, we needed to complete step one, which was to begin stream assessments across the entirety of Rock Creek Ranch. We began this process in the fall of 2025 using this guide pictured here, which is the threat-based management for creeks, streams, and rivers, specifically for sagebrush systems in the Pacific Northwest. And we used that to develop our methodology. We then walked the length of all streams and headwaters of interest across the ranch. And to do that, we had to divide them into reaches or short segments. And these divides occurred at visible barriers such as roads, fences, natural physical divides. You can see an example of what that looks like here on this map, where each reach of Rock Creek is shown in a different color. We've got green and then red and then sort of that bluish purple color. And dividing streams into small segments like this can help us assess functionality at a management scale. And so this is really suitable for determining your next restoration project by helping us pinpoint exactly where restoration actions might need to occur. So we divided into reaches. And then as we walked those reaches, we noted points of interest for each reach, took at least 3 photos showing its typical appearance, and took notes on its various attributes. This included looking for things like erosion and head cutting, upland encroachment, and the presence of or lack of riparian vegetation, as well as things like meanders and point bar formation in a channel. And finally, after taking all of those notes into consideration, we assigned each reach one of those 5 previously listed ratings to help us understand where it fell within the degradation process and whether it was actually in need of restoration. These are just some examples of some of the ratings that we assigned particular reaches. So using those methods, we actually surveyed 88 reaches or stream segments across the ranch. This covered 55 miles of riparian zone, which is about 58% of riparian miles available to survey on Rinker Rock Creek Ranch. And most of these surveys were on ranch property, but they also extended to IDL and BLM lands whenever streams crossed ownership boundaries, which did happen. Um, it also included mini surveys within the Glendale fire perimeter, which is a fire that burned a significant portion of the ranch and surrounding public lands in 2024, and which is shown by that light red color on the map. And as I mentioned previously, um, fires can play a large role in stream functionality, so I wanted to touch on this because we know that they can cause large shifts in stream functionality due to the loss of riparian vegetation and increased erosion. So fires can actually cause a stream to transition to degraded pretty quickly, and this is concerning for managers hoping to see functioning riparian zones. And so for us, we wanted to make sure we focused on stream reaches within this fire specifically. So, of those 88 reaches that we rated, the majority of them were either functional at 36% of reaches, so they're doing great, they're doing, what we expect them to do in this system, or the other portion of reaches were most commonly degraded, which is about 30% of the reaches that we surveyed. And then the remaining reaches were either rated as recovering functional at 14% of reaches, vegetation impaired at 11%, or channel impaired at 9% of reaches. So that was our least common rating. When we considered the number of reaches within each of these categories that was disturbed by the Glendale fire, which is that 2024 fire I mentioned previously, 9 out of 26 degraded reaches were impacted by the fire, while 6 out of 32 functional reaches were impacted. And just as a reminder, those degraded reaches were experiencing both vegetation and channel impairment, likely because with the loss of riparian vegetation in the fire, you're more likely to see loose soils and increased erosion, and it's kind of a feedback loop. And so, with those results in mind, I just wanted to run through a few examples of stream reach ratings at the ranch. So first, these two reaches are in pretty different places on the ranch, but you'll notice they look similar and have quite a bit in common, including low soft banks, multiple age classes of willows, sedges and other true riparian species, meanders and water or sediment retention, as well as a large floodplain. And you can tell that there's good floodplain access because the vegetation isn't just green within the channel itself. It's not in like a narrow strip right by the channel, but that grass actually extends well beyond the channel, signaling adequate access to the floodplain. And so, using all that information, we rated both of these reaches as functional. All right, and so let's do another one. These reaches are also in different places on the ranch, but they both have, or they lack riparian species. They have woody riparian species that are stressed and represent mostly one age class. You can kind of see in the background of the image. On the right here, we've got a few willows. So there are woody species present, but they're all of approximately the same age class. And then we've also got upland species, both woody and herbaceous, that are moving in, and you can really see that in the image on the left here, where we've got sagebrush moving into the stream channel, which you don't want. So knowing all of this, we rated both of these reaches as vegetation impaired. They're lacking that riparian vegetation. And then finally, here's another quick example. You might notice that these reaches have some pretty severe erosion going on. They have invasive species moving in, and they're lacking in terms of riparian species, true riparian species, and that includes woody riparian species. And because they show signs of both channel and vegetation impairment, we rated them as degraded. And so those are just some of the examples of the mini reaches that we looked at last fall, but using all of that information we gathered for each reach, and in particular, number one, whether it burned in 2024, and number two, its rating, we then compiled a priority list. And so to do that, we used a key like this one here, which placed burned and degraded reaches as the highest priority, followed by burned, recovering functional, vegetation impaired, and channel impaired reaches, as well as unburned, degraded reaches. And so those highest priority reaches are shown in orange here on the key, and they're kind of highlighted. And notably, although we made this rudimentary key up, something similar could definitely be used in other burned sagebrush systems to help managers prioritize reaches for restoration. And then once we had that list, we could begin implementing some low-tech restoration structures. And so in October 2025, we started this process on the East Fork of Rock Creek, where we had a pretty major head cut starting within our burn. And this image was taken prior to the burn, but the head cut remained. And so we knew that this was a pretty high priority for us, especially with it being in a meadow, and meadows are something that are pretty important for sage grouse. And so with a crew of folks from the Idaho Conservation Corps, we installed multiple hay bales along the head cut, which will slow sediment loss and help stop the erosion from migrating and getting worse. And so here's some photos of what it looked like when we were in the process of installing it. And then here's what it looked like once they finished up. So that was our first restoration structure implemented within this project. You can see it required only a small crew. It's pretty low tech, relatively affordable, and that will hopefully stop that head cut in its tracks. And so as we continue to work within this rating system, our goals will be to use the ratings and priority list to establish a management plan for Long Gulch, much of which burned in 2024, and that's this area over here. And so that's one of our highest priority sections of the ranch that we want to make sure we're putting some structures on. And then we also want to work with partners and other agencies to get approval for more low-tech restoration projects, including BDAs and post-assisted log structures across property boundaries. And this should help us implement change at the watershed scale, something that is not super commonly achieved. And we're hoping that all of this can take place in the fall of 2026. And now, moving on to a bit more of a methodology note. Um, in the process of thinking about how we assess stream quality and prioritize areas to begin low-tech restoration, we also began to think about other ways managers have gathered data. And initially, as you saw in the methods section, we gathered stream degradation data in the field using this manual. You'll recognize it from the first half of the presentation. And we rated streams using visual cues of degradation and functionality. So we didn't have to take any measurements, but it was all field-based. However, there are other ways to gather data on stream status, including using remotely sensed data. And so one source of information is the Riverscapes Consortium, which contains RCAT or Riparian Condition Assessment Tool project files that can be downloaded for use within the QGIS mapping interface. And this picture here is an example of the project file for the Magic Reservoir and Bigwood River area. And so RCAT is a relatively new desktop assessment tool that uses three different data streams, including land use intensity, departure from historic conditions, as well as floodplain accessibility to come up with a single functionality rating for each stream reach. And these values range from 0 to 1, with 0 being very poor condition and 1 being basically perfect condition. And so you can see how these 0 to 1 ratings in RCAT may be similar to those ratings spanning from functional to degraded that you recall from our field surveys. There might be some overlap there. But these two rating methods do actually differ in their inputs. You can see some of the things we noted in the field that helped us determine each reach status on the left, which included things like head cuts and upland terraces and stress levels of the riparian vegetation and the encroachment of upland species, all things that we touched on in the first part of the presentation. And then some of the inputs for RCAT ratings on the right, including floodplain access and those historic inputs that I mentioned on the last slide, like conversion from riparian vegetation to conifers or invasive species, and conversion to agricultural lands, etc. And so these differing inputs already mean we might get different ratings for stream reaches. But still, we wanted to know whether these approaches to rating streams varied in other ways, such as time and funding needs, reach designation, and rating output. So, in other words, we wanted to know, are these methods interchangeable and do they give us matching results? And so we compared them. First, we looked at effort, or how long each of these methods took. And for the field-based surveys, I spent about 2 weeks in the field, followed by about 1 week cleaning data and creating a simple ArcGIS Pro map. While for the RCAT results, I spent a couple of days learning how to actually use QGIS and QRIS before pulling reach ratings from the correct project file and averaging them. And this took about 1.5 weeks compared to the 3 weeks of the field survey. So RCAT ultimately took less time and effort. However, I'll note that this is super project dependent. And so it will depend on the mapping literacy of the person working on this project. If they already know how to use QGIS and ArcGIS, it's going to be a lot faster for them. And it also depends on how far away your field sites are. There are a lot of things that might go into this, but ultimately, in our case, the field surveys took a little bit longer than the remotely sent surveys. So next, when it came to reach designation, we had some pretty interesting differences between what we called unique reaches in the field and what RCAT called reaches. This is probably at least partially because RCAT uses the NHD-based reach designation, as you can see on the right, which looks at things like confluences, major tributaries, water body boundaries, etc., to make those reach designations. Whereas our field surveys, if you recall, use things like fences and roads to break streams into those short sections or reaches. And so when comparing the two, this meant that RCAT occasionally ignored what we considered boundaries, those roads and two tracks. And it also broke down a lot of our reaches into multiple segments based on qualifiers that we actually couldn't see in the field. And you can see an example of that here, where RCAT took one of our field reaches and divided it into 5 different reaches, which are all shown in a different color here. And this was actually pretty common. In fact, on average, one of our field reaches contained 3.6 RCAT reaches. And this meant that in order to compare ratings between methods, we had to average ratings between those RCAT reaches to get an idea of how the RCAT ratings compared to our field ratings. Because we had, let's see, one rating for this entire section, and RCAT had 5. And so that wasn't ideal, but it's just something to note. Additionally, reaches sometimes appeared to follow the lowest point in RCAT and not the place where the actual reach was located. And so this image shows an example of this displacement at Rinker, where you can see the RCAT reach on the left there in that sort of brighter greenish yellow smooth line. And then you can see where the actual water was flowing with this hand-drawn line here in the lighter yellow on the right. And displacement of reaches like this might mean a mismatch between method results, since some reaches will therefore be pulling from different location-based data for that reach. For example, pulling from information right here versus right here, potentially resulting in different ratings for those reaches in RCAT. Another difference between the field survey and RCAT was the missing ratings for some reaches of interest. For instance, you might have entire streams like Little Poison Creek pictured here that go unrated by RCAT, instead getting this dotted line rating due to the valley being considered too narrow. And you can see that in this list of riparian conditions here. The final possible rating is valley too narrow. And so these NA or not assessed reaches still have info on conversion from historic riparian cover and floodplain access. That's all still there, and that's all very useful information. But we're actually missing that condition rating that we hoped for. Down here, you can see that there's a -1, which is just a placeholder. And so those reaches actually weren't rated. And so, statistically speaking, 52% of field reaches had at least one unrated section in RCAT, and 31% of field reaches were entirely unrated in RCAT, which is not super ideal. And then, in terms of how each of these methods assessed stream reach functionality, we did actually note some differences. And you might recall the results on the left here from the first half of the presentation. These were the number of reaches we placed within each category during field surveys. And then now you can compare those numbers to the distribution of ratings on the right, where RCAT placed just 3% of reaches within the poor category compared to our 30%. And they placed about 40% of reaches within the good category, which is actually pretty close to our 36% of reaches that we rated in the field. Oops. And so overall, there was a pretty solid match between RCAT and field ratings when conditions of reaches were good. But once reach condition began to degrade, RCAT wasn't picking up as much on those cues like we were in the field. And so, more examples. These are some examples that help illustrate the difference between what we saw on the ground and what RCAT was seeing remotely. We rated this reach as degraded because it has little riparian vegetation, some severe erosion in places that you can't see that super well in this picture, and it's showing stressed vegetation and lack of access to the floodplain. And yet, RCAT still rated this reach as good, so you can see that this is ultimately a rating mismatch between the two methods. And here we've got a reach where we were seeing steep banks, clumps of soil falling in, veg falling into the stream, and bare ground. And so we rated this reach as channel impaired, since there is still some riparian vegetation present, but the erosion is pretty severe. However, using remotely sensed imagery and historic input, RCAT instead rated this reach as being in good condition. So again, we have another mismatch. Now, this one is an example of a good matchup. In the field, we saw multiple age classes of woody riparian vegetation. We saw plenty of herbaceous riparian vegetation. There was good sinuosity of the stream. We were seeing meanders, and there was very little to no erosion. And so for that reason, we rated this stream as functional. And RCAT actually agreed with that rating, so this was a rating match. And finally, another thing that makes RCAT different from our field surveys for reach assessment is that historical land cover information that it pulls from to rate reaches. That's something that we don't have access to in the field. So using RCAT, we were able to look at land conversion proportions for reaches of interest. And in this case, we looked at reaches that we rated as degraded. And as you can see, 45% of degraded reaches were experiencing some level of conversion to invasive species from previous conditions. 59% were experiencing conversion to agricultural use, and 100% were seeing conversion to grass and shrub cover. So that's non-riparian, that's upland grass and shrub cover. So this is just an example of something that you can get from RCAT that you actually cannot get when you're out in the field doing these surveys. So to sort of sum all of those results up, here are some general considerations to take into account moving forward. First, field surveys allow for more intimate knowledge of each reach and give context about the landscape. This includes the ability of managers to take photos along each reach, as well as to note key points showing extreme erosion, beaver dams, any other information that you might find interesting or useful in the future when it comes to planning restoration actions. However, field surveys are also more time-consuming, project dependent, and they don't operate off of historical information. RCAT processing of reaches takes about half the time of field surveys and incorporates historical knowledge of each reach, something that our field surveys don't. And it also includes many other interesting metrics in its output that could be used for analyses, as well as land ownership. And I'll note that time of year is not actually a barrier to getting data, which is really, that's pretty great. However, it's also less personal, so it's less detailed information, including less detailed vegetation information. It may have inaccurate reaches, or it might skip smaller reaches. Plus, it might miss key features that impact ratings, such as fires. So I'll note that when looking at the reaches that were impacted by fires, it didn't seem that RCAT was actually taking into account the fire. And so that's just something to keep in mind moving forward. I'll note that we're hopefully going to continue working with folks across agencies to come up with recommendations for when to use each of these methods and are hoping to dig into the timescale and resolution of each because those things likely vary. But for now, when thinking about which method to use, you'll likely want to consider all of these points in the slide in the context of your presentation goal, or your project goals to help you decide which route to take. All right, so that's all I've got for today, but to sum up the future of this project, we'd like to continue implementing low-tech structures in 2026 and specifically the fall of 2026. We'd love to collaborate with others and discuss the use and current status of RCAT within the field of restoration. And lastly, we hope to eventually, maybe in the near, far distant future, to incorporate grouse movement and survival and brood data relative to these low-tech restoration structures to sort of help us examine whether low-tech process-based restoration actually benefits grouse populations down the road. Um, and so thanks to everyone for listening, and thanks to Eric for setting this up and giving me a chance to talk about what we've been up to. And next, I think we've got some time for questions and discussion. And then finally, I'll just leave this up here for now. These are just some useful links for folks that might be interested in the field guide we use, that threat-based management guide, and also a lot of links to RCAT information.
Thank you, Kirby. Yeah, this was great to hear all the updates. We do have several questions in the Q&A that we'll work through now. I will
Great.
also remind folks, we do have another webinar in February. This will be a continuing webinar series. Our next one will be February 26th, Thursday, same time. We'll have Dr. Tim Prather of the University of Idaho talk about native seed banks at that one. But let's get into some of these questions. There's some great ones here. So the first one, is the presence or absence of surface flow accounted for in the assessment? And kind of is it assumed that all streams surveyed should generally have surface flow if functioning properly?
Yeah, I don't know. I'm assuming that's the field survey assessment. I'm not sure if that's referring to the RCAT assessment, but for the field surveys, yeah, we with the main stem of Rock Creek, we pretty much it's a perennial stream. It was pretty much always flowing, but we did survey streams that were intermittent or were headwaters, where we knew that there weren't always going to be wasn't always going to be flowing water. And so when I was in the field, I wasn't necessarily looking for flowing water as something that would guarantee because we were surveying different types of streams. Water retention, especially in a perennial stream like Rock Creek, is certainly important. But I don't know, Eric, do you have anything you wanted to add to that?
Yeah, no, you did it well. Yeah, so we did have a lot of intermittent streams, and so surface flow wasn't necessarily um, assumed to need to occur to be considered functional. Okay, let's see. The next one, were your methods primarily qualitative, or did you use a particular quantitative protocol to determine the degradation, veg, et cetera? And I think this one's more for the field assessment.
Yeah. Yeah, it's primarily qualitative. There was no, there was no exact science to this necessarily. There are a lot of visual cues that you're looking for that will point you in the correct direction as far as showing you where that reach is at in terms of its whether how degraded it is. But yeah, I would say it's primarily qualitative. You're looking for specific species of riparian herbaceous riparian plants, specific grasses, specific woody species, um, and you're taking note of those and what their age classes are and that sort of thing. But as far as there being an exact step by step, or we don't measure the amount of erosion that's happening, for example. It's all a bit more qualitative than that. Do you think that's fair, Eric?
Oh yeah, yeah, definitely. Yeah. It's looking at indicators of channel impairment or vegetation impairment. And it's meant to be very fast, um, sort of assessment that will then help us determine where to go and do some um, more detailed assessments. Let's see. Another one is the meadow with the erosion head cut where you installed the hay or the straw erosion control methods within a grazed area. And do you have a plan to protect the bales from livestock until vegetation is able to establish around them? Um, Maybe I should answer that one.
Yeah.
So that is within a grazed area, but since it's also within a burned area, we're holding off grazing on that particular pasture for at least one other year, and then we'll start assessing um, when we might return grazing in there. It is straw bales that we used and not hay, so that hopefully deters some wildlife and livestock use. We also used some wildlife deterrent sprays on those bales to hopefully deter wildlife from trying to consume them. Let's see. Here's
Yeah,
one.
sorry, that was my fault. I misspoke.
Yeah, no problem. That's what is the spatial coverage of RCAT?
Yeah, so the project files are within certain watersheds. They're limited to certain watersheds, but my understanding is that much of Idaho is covered within RCAT. And I think Utah as well. I think a lot of areas in the arid West actually have coverage with project files that have already been developed that you can just go in online and download those files. That's my understanding at least.
Yeah, totally. There should be there on some of those resources that you showed at the end.
Yeah.
There should be resources there for other if other people wanted to do the same thing.
Yeah, I'll pull those up.
Here's another one on RCAT. How accurate would the historical information be if RCAT is mislabeling the condition of the riparian area? Oh, interesting. Yeah, so in other words, is the in the field you show degraded, RCAT says it's good. Do we believe the historical information that it's providing?
Yeah. Well, there are a few things going into the rating, and historical information is definitely one of them. I think something that we've talked about since running this like very rudimentary comparison of the two methods, is that we don't really know, and we don't know exactly where they're pulling that historical information from necessarily, and it's um, finding out where each of these where each of these sources is coming from is kind of difficult. And so we're hoping to start a conversation with the folks who actually developed RCAT to figure out where it's pulling some of this information from. So if that historical information is not accurate, then that would definitely play a role in the rating output. Um, for example, the agricultural rating, as far as conversion to agricultural land, what exactly that means, we're not, entirely sure yet. So yeah, I think that would impact our the rating accuracy in RCAT.
Yeah, so for like those areas, like there's no like agricultural being conducted at Rock Creek, so it's mostly historical, uh, probably hay fields because a lot of the vegetation is smooth brome, meadow foxtail that used to be used probably for hay production. So maybe it's cluing in on that, but it's not like there's cornfields next to the stream.
Yeah.
So it's a curious one.
And I'm not sure if it thinks about, grazing as part of that. I don't know if it's considering, cattle grazing, because we do have that at the ranch. So, that's something that I'd like to dig into a little bit more.
Okay, why is one class of willows bad? Or
Oh,
one age class, one way as one age class of willows considered bad.
yeah. Yeah, I think, and Eric probably has a better answer, since I was mostly the field help for this. But my understanding of this is that you want willows to be reproducing is not the right word as a wildlife person, but you
Yeah.
you um you want willows to actually be going to seed, growing. You don't want to just have one static age class of willows that isn't actually continuing to um, develop beyond just, mature willows, for example. And I don't know if that is entirely accurate, Eric, but
No, yeah, yeah, perfect. Yeah, that was a great answer. So it's basically if you're only having like a mature set of willows but no young willows, then you're something is occurring in that system that it should start raising alarm bells. Um, if you only have young willows and no mature willows, then maybe you're like, okay, well, something happened to wipe off the mature willows, but the young willows are coming in, so that might be good, something to be concerned about, but not have alarm bells so much. But if you're not seeing any recruitment from new willows, that's certainly something to be aware of and concerned about. And so you're just looking for that nice age distribution in the willow classes or cottonwood classes, if that's on your stream. Though this is a good one here. Are you developing state and transition models? Uh, kind of, for example, the Stringham and L state and transition models for riparian areas for the study site treatment sites. Um, maybe I'll take that one.
yeah.
And so the assessment, the field-based assessment kind of has a baked-in state and transition model to it. The progression is from, healthy to either vegetation or channel impaired, and then into degraded. And then there's a loop back to healthy or uh, recovering within that. It's not as detailed as some of the other state and transition models that Stringham has developed. Um, Certainly it's much more coarse, but it is kind of baked into that. And then we use that once we've prioritized our streams to work on, we develop a more specific, focused sort of process-based state and transition model where we are identifying the processes that are missing in these streams and then how we're going to go about and restore those processes and where that's going to take the stream, the steps that it's necessary to take the stream back to healthy and functional. Um, so that's a great question. And then another one is, have you established a monitoring system for the treatment sites? Do they include shallow piezometers for surface water, shallow surface water table response? I'll take that too. Yeah, we have done some monitoring for these treatment sites. We do both field-based monitoring with uh, vegetation cover, stream flow. There are a few shallow groundwater wells that we've established. We're also using drone-based imagery. We fly drones, both aerial imagery and LiDAR-based imagery over the sites, so we can evaluate change in productivity. We can evaluate change in channel geomorphology. We can evaluate change in vegetation size and how much the area has mesic vegetation versus upland vegetation. So, but those are mostly for the sites that we are focused on treating. But yeah, that's a great question. Let's see, a couple more here. Did you have any pre-fire assessments photos that you could use to compare with the post-fire field assessment? Um, and yes, we do. Um, Especially on the riparian areas, we were able to fly that with drones for several years before the fire and now have drone imagery after the fire. So we're actually looking at that to see how the fire interacted with those riparian areas. Some of those riparian areas did have active beaver dams and some were not active beaver dams. So we're evaluating to see if the fire severity shifted at all in response to those beaver dams and the riparian areas nearby. So that's some ongoing work. And that'll be really interesting to look into and delve into in the future and hopefully have some a better understanding of that. Okay, another one. How does the distance occupied by woody riparian vegetation from the stream course impact the characterization assessment? Hmm. Kirby, you want to take a shot at that?
Yeah, I mean, this isn't something that we were measuring in the field. So we were, and it was woody vegetation. Is that the
Yeah,
question?
woody
Okay.
riparian vegetation.
Yeah. We weren't measuring that in the field, but I can imagine that is similar to the looking at like the width of green vegetation around the edges of the channel. That would say something about floodplain access, I would think. So if you're seeing woody vegetation, woody riparian vegetation further out from the edges of the stream bed, that would be a sign that that stream reach has pretty good floodplain access.
Yeah, I'd concur with that. And with the RCAT assessment, do you think it folds into that piece too?
But as far as whether our cat is looking at
Yeah.
that, I'm not, it doesn't really seem like it.
Mm.
I've been kind of surprised at, from what I can find, how little it looks at the width of those green vegetation sort of bars on the edges of channels. Um, I can't find where it actually takes that into account. It looks like it's primarily, it seems like it's primarily historic floodplain access, though where they're getting that number, I'm not sure because it is a proportion. So I'm not entirely sure where they're getting that. It could be something to do with pulling from remotely sensed imagery of those reaches. Um, but I'm not entirely certain.
Yeah. Yeah. It'll be more to learn about how that assessment actually works in RCAT. They use that. Great. Well, I don't see any further questions in here, but really good interaction, really good discussion. And Kirby, thanks for all your effort there. And everyone, thanks for participating and asking some great questions. We do have a post webinar survey that you could take, please, and to help us understand how we're doing, and also to help us come up with other topics to consider doing webinars on, please let us know. And tune in next month, Thursday, January or February 26th for Dr. Tim Prather, work on native seed banks. And I think that's it. Oh, is there one more? Nope, there's saying thanks. So yeah, thanks a lot, Kirby. Thank you everyone for your participation.
Yeah, thanks for this opportunity, Eric.
Okay, bye.